the Vice President of ISAIL, Mr. Bogdan, and obviously Mr. Abhivardhan, sir. Welcome, Mr. Yuvraj, to the session. And there'll be to whoever's present here, there'll be 4 areas that we'll be covering in the very session. Firstly, how can the AI-based privacy-preserving tools be used in making public and private data use safer? Secondly, can the privacy-preserving AI techniques be helpful in enabling safer and a cleaner knowledge management practice for crucial private data? Thirdly, can the existing privacy-preserving AI practices be in line with the DPDP Act of 2023 or any other data protection laws? Or what lacunas the existing laws might have in order to incorporate such privacy-preserving practices? And lastly, but not the least, can the Web3 technologies be infused with these AI-based privacy-preserving techniques? And that being the last of it, over to you, Mr. Yuvraj. Please carry on to your presentation. I'll be asking you questions as once you're done with your speech. Thank you.
Thanks, Supratim. And thanks, Abhivardhan, ISAIL, for this wonderful opportunity. I think let me share my screen for the slide in just a moment. Yeah, just let me know when it's totally visible.
Yeah, it is visible.
Is it visible now?
Yeah.
So okay, that's good. So before even going into the presentation, I want to start with the thing that this session is of immense importance because I feel the law and the technology, they both, the people who are working on the technology, they both play a very crucial role in making privacy a reality. Because if there is no enforcement, people do not really have motivation in technology world to inculcate the privacy in their systems, because privacy is more or less sometimes seen as an overhead in terms of cost, and overhead in terms of complexity, and overhead in terms of different type of complexity that comes to the system. So it is very crucial that people who are there in law, they are enforcing these type of rules and regulations. But the issue that is happening, I think, not just in India, but globally, is that the law speaks a language, and technology, people working in technology, working with technology, with these tools and techniques, they speak a bit of different language. And that's where there is a small gap. And I think sessions like these, like the discussions we are going to have, the discussions like these can really help us bridge those gaps. So today I'm here presenting our startup FlintX. I have here with me Bharath as well. He's there. So we are a team of 3. So Bharath is CEO, I am the CTO, and we have Saurabh, who is the finance director. Okay, so before diving into the presentation, I'll tell you there will be 3 phases of this presentation. First, we'll be talking about a bit about data availability. Then we'll move to using private data for AI. So just to remind, this is not just about privacy of data. It's not just about looking into the different ways by which we can make the data private. It's also more about how that data is specifically used in context of AI when we are talking about privacy. So this entire presentation, whatever we are talking, all of it is in context of AI in some way or the other. All right. And finally, after building up all the motivation, we'll go on something like the reverse approach. You will understand what do I mean by the word reverse approach here by the time we have developed our understanding in using private data for AI. And that's what we do at FlintX, by the way. Okay, so let's begin. So about data availability. So there's a lot of data. We all know that. And for AI, the foundation of AI is data. If you do not have good data, it doesn't matter how good of an architecture, how good of a techniques you use, the model will not have a good accuracy. The model will not have a good kind of performance. So there needs no facts or kind of stats to support this fact. I think everybody among us understand that data is a prime need for building good AI systems. So let's talk about the data availability now. So what do we mean by data? So the existence of data is there. There's a lot of data. There are zettabytes of data. That is billions of GBs of data. That is there. But what about the availability? Because we want to train our models. We want to look into the availability of the data. So I'll give you a small stat here. That is only less than 10% of the data on the entire internet comes under open web. What does that mean? That basically means that more than 90% of the data is behind some kind of signups, logins, paywalls, etc. So that is not an openly available data. And a lot of it is actually private data in some way or the other. So you'll understand that while we have such a huge existence of data, the data which is openly available is very less. So if we are talking about public data sets and everything, they are very small in comparison to the number of private data set and the amount of private data set we have that we need for AI systems. So that is where the issue is. So that's what I am showing here in the slide, that if the total data set on internet, let's say it's around 150 ZB. So the 10% of it, which will come into the open web part, is like 15 ZB. That is more than like 15 billion GBs. So now when I was saying that 10% is less, but 10% is still 15 billion GBs. But it's still not enough. It's still not enough. What I'm trying to motivate the cause here is that even though this data is in billions of GBs, it's still not enough to train all the AI systems we have today, because this is a generic, this stat is about generic data for different applications. The data sets are limited for different applications. For some applications, there is more data sets, for some there is less. But even if you see it in an overall way, in an exhaustive way, let's say large language models is an example where the data is not very specific. They use like almost all type of data. So even for large language models, if you see that this graph shows that by 2028, we will be done with all the public data set we have to train our large language models. Now, it is not even about that the domain is very specific, that we are not getting data. It's large language models, they take all the type of data. And even in that case, the data is going to get exhausted at the rate which we are moving by 2028. So I think I've established the fact that the public data is very less in comparison to private data, and we have to tap into private data. And this is not an option, this is a need. So now we be talking about how we can tap into that private data, how we can use that private data, right? So when I say use that private data, it basically means using that private data without breaching the privacy policies, without breaching the privacy policies of individuals, organizations, countries, etc. So, like the first thing which comes to people's mind when they think about like if you have to give away a data set, why just don't do anonymization and just give it away? So this is like the very naive or first thought that comes into anyone's mind when they think about like sharing a private data set, that you do anonymization and share it with people for training. But you'll be surprised to know that anonymization can be reversed. There are different techniques by which people can re-identify from the anonymized data. And I have put like two like simple but like very famous examples. The one is that in 2007, Netflix has a price case in which the researchers re-identified 480K anonymized users of Netflix just by linking movie ratings and public data. And on the other hand, I have displayed that 80%, 87% of Americans can be uniquely identified using just gender, zip code, and date of birth. So what I'm trying to say here is anonymization has always been seen as a way to kind of create private data set available to people for doing research, training models, and everything. But they suffer these type of attacks in which they can be re-identified. And it's very common these days. So like I would like to ask these questions to like I'm just putting this question here, that when like in law, when we see these type of questions that okay, when you are providing data set, it has to be anonymized, but there is no discussion about the guarantee of anonymization. There is no discussion about the way people are doing anonymization. So anonymization can be done in so many ways, right? If the law is just saying that what we need is anonymization of data before sharing, it could be done by several ways by the people who are working on the tech side. And depending on the way the people who are working on the tech side decide, the vulnerability of data set is also determined in some way or the other. So this is something I feel there is a gap between when in the law, when simply it's mentioned anonymization, and when somebody is kind of implementing it, because the degree of security that is ensured from it depends on implementation to implementation. So if anonymization is not the way we can do it, I have also shown an image here, like which gives you an idea about how people could do that. For example, you have anonymized Netflix data, and then you have a public but incomplete IMDb data, and then you can kind of match it to finally figure out who was who. So that is like linking attacks and all that, which happens on anonymization data. So if anonymization of data is not enough, what are the techniques we can actually use to provide these private data set to people who are building models or people who are training models? So now I'll be talking about that. Okay, but before that, there's one more thing to add into it. And that is, when I was saying there are various ways by which people can do anonymization. So you see that depending on the re-identification risk, so leave the synthetic data aside, because synthetic data is something which is very hard to create in most of the cases, and it is not something you can generalize. So I kind of leave it aside for some time. So let's say you use randomization, permutation, aggregation. These are just name of the techniques. So what happens is, if you have like a if you want a good ML performance from that, so if you anonymize a lot of data, like you completely anonymize the entire data set, then what will happen is it will negatively impact the ML performance. The data set will not stay good enough. So if you just keep doing anonymization and anonymization, that doesn't mean you can make it private, but then it is of no use for ML performance. So that's what happens. So as you can see, like uh, here, for example, the pseudonymization technique, the ML performance will be very high, but the re-identification risk will also be very high. So it's like you have to choose between the two. So coming to the techniques, like anonymization we saw is not working out. So what are the other techniques people are using? So this is a concept called privacy enhancement techniques. So this is an umbrella term which have multiple type of techniques or technologies inside it. So the first one is the homomorphic encryption. I'll talk briefly about that. Then I'll go to differential privacy and how these two techniques are used to make those private data sets available for people to train ML models. I'll talk about that a bit. And finally, there is one more technique in privacy enhancement techniques that is called secure multi-party computation. I am not going to go into that because I personally don't feel that people have achieved like a good methods of using secure multi-party computation for training machine learning models. And to keep the scope of this presentation in mind, I'll not go into secure multi-party computation for now. So let's talk about this technique called homomorphic encryption. So what happens here is, we all know what is encryption. Okay, so it's very simple. You encrypt some data. The only difference between homomorphic encryption and a normal encryption is, in homomorphic encryption, you can actually do operations on the encrypted data itself. So what I'm saying is, let's say I have number 2 and number 4 with me. I encrypt both of them, and then I add their encrypted format, not by after decrypting. I just add their encrypted format and I decrypt the result, and it will become 6. So that is what homomorphic word means, that even in their encrypted form, they can be added, subtracted, multiplied, and multiple other operations that can happen on that. So now talking about this technique from a AI perspective, what can happen is you can actually train your models on homomorphically encrypted data. So if you have a model that is trained on homomorphically encrypted data, what you can do is you can have your data that is encrypted, you can send it, the model can do the inference, and it is happening on the encrypted data itself. You don't need to give away the private key to some third party for decryption or doing something like that. And you get the encrypted result, and then you decrypt it on your side. So that is what is there. That is what homomorphic encryption enables. But for that, you have to kind of train the model in such a way, you have to have the architecture, the data set in such a way that it can work on homomorphically encrypted data. But once that is in place, so you just never need to kind of decrypt your data outside your device or outside your organization, and you can still take help of models which are outside your device and your organizations again. So that is the very good use of homomorphic encryption, and that is where it's really helpful. Coming to the second type of technique, that's called differentiable privacy, maybe the easiest among all the techniques to understand. So it's basically that you kind of say that I have data and I'll just add noise to it. So noise is like random, I'll just add random values to it. So what you get is a data with noise. So this is very natural and intuitive to understand. So I have just given you an example when the United States Census, this was I think 2020, they shared this thing that the census data set they are making available, they will apply differential privacy on it. And they showed that like if you go for like a very high accuracy, the privacy is less. Why is that? Because if you go for a very high accuracy, you are not adding any noise at all. If you're not adding any noise, it just means the data is the way it was. So the moment you start adding noise to it, the accuracy starts dropping. And if you come here where privacy loss is least, which means it's completely private, that means you have added so much noise that there is no meaning of the data set at all. So that's why it's written no accuracy. So what happens is differential privacy, you might think, okay, adding noise is a very like basic concept, or it's very easy to like when you hear about it, it's nothing fancy. But you're surprised to know a lot of systems like even Google uses for user privacy, they use differential privacy a lot. The reason because why people use differential privacy is you can actually have mathematical guarantees on how much privacy you are providing. So for other techniques, it's very hard to formalize that how much secure the system is. But for differential privacy, you can actually mathematically deduct and say that these are my privacy guarantees. And that is why it is easy to put it in like kind of contract forms and stuff. So that is why differential privacy is also widely used. So I talked about homomorphic encryption. I talked about differential privacy. I'm skipping secure multi-party computation because that's not very relevant for training of the models. Now I'm going to talk about our work, our approach that I have like mentioned as reverse approach. So what do I really mean by reverse approach? Let's talk about the conventional approach first. Let's say there are multiple organizations. It could be organizations or it could be users inside the organizations as well. So what we are trying to do today is in a conventional setting is that we take all the data to a place where this model computation is having. When I say computation, it can mean training of the model, inferencing of the model, and things like those. So what we do today is that we take all this data somewhere else. And when we have to take this data to somewhere else, which is not a trusted party and which is another party, then all these issues of like making the data private, anonymization, homomorphic encryption, differential privacy, and everything comes into the picture. These all overheads are there because we are taking the data out of the premise. What if we could keep the data in the premises? If we could keep the data in the premises, that means there is nobody looking into the data. That means we do not need to alter the data set. We do not need to encrypt it. We do not need to add the noise, or we do not need to add anonymization to it. And if we do not do it, the data stays at a very good quality because it's not been touched, it's not been tempered to maintain the privacy. It's in very good shape and it's very good quality. And the better the quality of the data, the better the models are. But if that was so trivial, why were people doing it all wrong for this long? So that is very intuitive question, very natural question. So the reverse approach is basically the model computation goes to data. So here I'm showing this as a box, which basically means the computation, training, and everything is happening on the premise itself, or if it is a user, then in that case, a device itself. So this is the reverse approach. Now again, why is that people were not doing it? Because there are two major challenges to it. First, the organization or the device of the user, it could have a lack of data and compute resources. What does that mean? For example, like I want to have a model for facial recognition, but my organization doesn't have enough like photos of faces. That means I do not have enough data set. So if I do not have enough data set, how would I make this possible? How would I do entire training on my own premises? So lack of data, compute resources, as in like I do not have GPUs, how could I do that again? So like because training models is like a big thing. So that is one issue. The other issue is, let's say I do have like budget for like building some compute, some infrastructure. I do have data as well. I mean, you look into any government organization, like you'll see like they have kind of, I think, budget in some way or the other to afford some kind of infrastructure. and they do have a lot of data, like government organizations, they do have a lot of data. But where they lack is the lack of ML expertise. So I think that there are two issues with this reverse approach, where we are trying to kind of do the compute on the data, the place where data set is already there. The first is that there could be lack of data and compute resources. The other is lack of ML expertise. And this is the challenge what FlintX is trying to solve. So talking briefly about the first challenge, that if there is a lack of data and compute resources, we use some technology called federated learning. So in that, what happens is you kind of train the models on your organization, on your premises itself. We know that you do not have enough data, enough compute, so you won't be able to train it fully. It will be a partially trained models. What we do is we collect those partially trained models, we combine them and send it back. And then you repeat this process until you get the convergence. So in this case, there is migration, but not of data, but of these model weights. So this technique in itself is called federated learning. And this is something that can be used to kind of fight from the challenge of lack of data and compute resources. So that is one thing. And the very latest thing, something like we are very, very excited about, and like we are developing in that direction, and it can become a reality today because of this like a lot of kind of research and development from the development side as well in the agentic AI system. So now something that has become possible is you can replace the part of ML expertise. A multi-agentic framework can actually replace the part of ML expertise. But let's start with the story. Like, why do we actually need it? So, for example, there is an organization which lacks of ML expertise, right? They can't do it in-house because of this. So what they do in a general case is they hire consulting firms. There are many AI consulting firms. Their work is to like take these AI related problems from an organization, take their data set, build solution and give it to them. That's been happening for a long time. But sometimes what happens is the data set they have is kind of private. So if the organization's data set is private, they cannot share it or outsource. They cannot share the data set with the consulting firm, and they cannot outsource their work of machine learning. Now, there is one gap, that if I cannot hire consulting firm, I do not have like ML expertise. What do I do now? So that is a gap we are filling with FlintX again. And how do we do that? That's very interesting. So what we do is we provide our technology, which is confidential containers. We call it FlintX Smart Confidential Containers. This was written on the first slide of the like presentation itself. I didn't want to go in the beginning, because now you can actually understand when I'm showing this slide, what does that actually mean? So what does that actually mean is that in an organization, the tool we are providing is, first of all, let's say you will give the requirements to the confidential container. We plant inside your premises only. Your data is not coming to us. You do not need to go worry about the technologies like encryption and everything to send the data to us, because our confidential container is sitting right there on your premises. It's not coming to us. We are not able to see anything, any type of data, any type of thing that is happening inside. So this magical container, what it does is it takes the requirements from you. Because it is on your premises, it takes and kind of connects itself to the private database you have. And it has a multi-agentic framework that kind of converts those requirements into different sub-requirements, which are fulfilled by different agents, which are provided inside the container. One more thing to add here is you might wonder that, okay, we are using this agent, so are we making any calls to OpenAI? Are we making any calls to Claude? Or are we making any calls to like any LLM provider present in this world? No, we are using on-premise LLMs for this purpose. So even if you turn off the internet, this system will still work, because all it needs is this premises. The agents are actually powered by the language model that is already there on your premises, deployed by us, and it's present inside the confidential container. So that is what the concept is. That is where it is. If you have to understand it in layman words, you can think of it as that there is a ML engineer who has gone and sat inside your premises, and he is doing work for you. So that is what we are doing through our multi-agentic framework. in a confidential container environment. And by the way, we also have, so if you do not have those type of premises and all that, if you do not have those infrastructure, you can also utilize our technology by the use of trusted execution environment. So that is also something like if you like, I'll not explain it right now, but if it comes up in the discussion later, I love to like take questions on that. So that is what the technology is. And again, this is a form of federated learning we do between the containers to make the system better. And finally, like for us, our unique selling points are like we have on-premise intelligent solutions ensuring zero data security risk because data is not leaving, demands lower technical expertise because this multi-agentic framework is taking care of everything. And finally, combines multiple model optimization techniques into the automated workflow. So I think, yeah, that's like more of what we are doing. And like giving, I think, Abhivardhan, what do you say? Like, I think I have like already taken 20 minutes. If you want, like I can like go through quickly few more slides, or this much is also fine.
So let's do this. I believe Supratim might have some specific points, maybe at a 101 level to start with, and then
Sure.
I will be happy to intervene. But let Supratim do it because after then I'll let Bogdan ask some questions. I'm pretty sure he has some questions on this
Sure.
because we are happy to understand to the extent we have explained. Because see, even in our line of work in law and technologies, we more refer to primary sources like AI papers than the so-called regulatory literature, which is actually hogwash these days, unfortunately. Be it
Okay.
India, Europe, or US. So it is what it is. But Supratim, over to you. Then maybe Bogdan can add up. Yeah.
Hello. That was a beautiful presentation. I had two
Thanks.
questions in
Sure.
the for the very same. You had previously mentioned that anonymization of data is one of the ways to tap into the source of private data.
Right.
And I wanted to know like how does like anonymization of data like adhere to various privacy policies in place? And secondly, like you also mentioned that AO like anonymization of data is detrimental to like machine learning tools. So I would want to know more about that. That's
Yeah.
it.
So can you please repeat the first question? Like I like
Sure.
didn't totally get that.
Okay, so yeah,
Supratim, I'd give a
yes, sir.
feedback to you. If you can make the questions a bit simpler, I mean, you have to understand
Okay,
that this is a multidisciplinary audience, and those who
got
are watching or will watch, and those who are obviously speaking. So I think that way it's, explain like
perfect.
Richard Feynman, basically, or ask like Richard
Got it.
Feynman. I'm a fan of that guy,
Okay,
but yeah.
got it. So how do you think anonymization of data, like why do you think anonymization of data is like detrimental to machine learning tools?
Okay. I'll answer this question first, and then we'll go to the
Yeah,
next question you had. So what happens
sure.
is when you do anonymization, like a lot of techniques are there. Like I'll explain it with a very simple technique. Let's say you are doing an anonymization over a data set of students in a school, right? And the very first thing you can do is you can just remove their name from the data set. And you can just give this data set to people for training the models, right? Because now it has been anonymized. You cannot figure out like what information is like Supratim's, what's Yuvraj, what Abhivardhan's, right? So this is like you did anonymization from your side, but this is not effective because like somebody can look into the parent's name, then he can look into the address and kind of, this is called a linkage attack. You are kind of linking multiple informations which are still available in the data set to deduct who could this person be. So you have to now remove one more field from it. Let's say you thought like you can remove address also, you can remove father's name also. Now it is anonymized. Like depending on what other fields are there, if linkage can still be done or not. But what you can see here is we are progressively removing the data from the entire data set to do the anonymization so that people cannot link things together, and you are kind of degrading the features. This is called like features because these are the features of the data set. So the diversity of the type of information that is present in the data set is getting reduced with time or with your steps to make it more randomized. And that's where you are feeding lesser information to the model, and that's where it's deteriorating the performance. I hope that
I
helps
understand.
like understand the question.
Yeah, definitely. My
Yeah.
last question for this: to what extent I love the slide on homomorphic encryption. So a
Sure.
question about that. to what extent do you think homomorphic encryption is like more efficient or more tailored to like than as opposed to regular encryption methods especially with respect to like privacy concerns?
So I think for normal encryption methods, what happens is not all the encryption methods allow you to kind of like do operations on the encrypted data. If that's not the case, let's say there are two parties, right? Like that's here is me and there is you. So I have some kind of requirement. I want, let's say, some kind of, and let's say there is a data set of me from my smartwatch telling all my heart rate from like last 30 days, right? Now I want some kind of report on that. And I do not have that expertise. I need your help. Let's say you are the person who provide the analysis on the heart rate or heartbeat. So I have to send my data to you, right? So if it is a normal encryption, I have to encrypt it, send it, then it will reach to you. Then you have to decrypt that and then perform the analysis. So you become a trusted party for me. I have to trust you. So that's not happens in real world. Like even in policies also, I think I'm not that aware of all the policies, but I feel like sharing the data in this way is not how things can work. So if you are doing a normal encryption, the only thing you are ensuring is between me and you, nobody saw the data. But homomorphic encryption is something that even you don't see the data. It's just me who's the owner of the data should see the data. So in homomorphic encryption, you encrypt the data. Like I encrypted the data, sent it to you. You wrote your algorithms in such a way that it works with the homomorphic encrypted data. It do addition, subtraction, the way that it happens with normal numbers. It can happen if it is encrypted on the homomorphic encryption methodology. So that is where a difference between normal encryption and homomorphic encryption comes, that even the second party, the third party, they also don't need to decrypt it to perform operations on it. And yeah, so that is one thing, that's a distinction. And like coming to the other part of the question, which is like how effective it is, and if it is that good, like why don't everybody adopt this? The reason is at the end of the day, it's encryption. Encryption is always a very compute heavy process. It's not like you can encrypt every data that's present on your phone in a homomorphic way, because it's very compute heavy. And when you have, let's say, GBs, TBs, and zettabytes of data, like encrypting it is like a huge cost. So the cost is like the compute cost is like the biggest hindrance in adoption of homomorphic encryption. That is first. The second is obviously not all the type of operations you can do on encrypted data. So there is a limitation to that as well. So I think these are the two reasons where the homomorphic encryption is also limited and not a universal solution to every problem you have.
Thank you so much. That's all the questions I had. Over to you, Bogdan.
Great. Bogdan, I think I'll be happy to have your intervention because I certainly believe you will have some questions in point. So, uh, Yuvraj, feel free to interject Bogdan in a polite way because he's a bit long, but for good. So, Bogdan, please, it's up to you. And it's great that we have it in an expositional way. So, please go ahead. On to you. Yeah.
If we go back, not on, I think one or two slides. Next one. Yeah, the one when you show the distributed, the containers. No, had a few containers that they're the same.
I'm going to just yes.
Yeah,
yes.
This one. So the org premises means public cloud are totally excluded. We have to be very clear on that, because public means well exposed. So no matter what container you have, you're exposed and of course hacked and eventually also sued, because we're talking privacy. So public cloud will jeopardize the whole model. Private cloud, fine, probably fine, and on data centers or anti-data centers also fine, but not public cloud. So when we talk, say, Google, no way. And Google meaning if people use the solution to say, we're gonna use this solution because, hey, first of all, it's not complicated solution compared to the challenges that it has to solve, right? So obviously there are complexities, but this is not a complicated solution. Then the users are using, I don't know, Google Docs, let's say, or MS Office 365. Just two example, like for some reason people are hooked into them because they don't have alternatives, or maybe they consider to be great when in fact they are, well, from the private perspective, they are just awful by design. So that will jeopardize the whole model. Why? Because first of all, the user devices will be probably fingerprinted. That's one. And then the data that goes ahead, it's essentially trackable, right? Because you showed that 3 data points to identify a person. True, all of them are personal data, but date of birth, it's actually SPII, pretty much. Postcode is just PII, it's not SPII, but also gender, it's also PII. But it's only 3, and you can identify a person if you know where to look. And so the device ID, it's actually more private than the postcode. It's in between that and the date of birth. But it's not only that, it's a host of other things collected, like the dot release of the operating system, the exact browser, the clicks, it's mind-boggling. Okay. And so it doesn't really matter if all this is on premises anymore. What actually equally matters is how is it being used by the end user, and the end user can be an engineer as well. It can be some product owner. It can be many people in the organization, depending on the roles and so back and so forth. So that's important to understand. If they have MS 365, which is cloud, public cloud, on the same machine, and the data from that machine, different data. Typically, it will be a lot of common data that goes into those Word spreadsheets and everything, I know, SharePoints and all those. But even if it's totally different, it comes from the same endpoint pretty much as what goes on the public cloud. And so the common denominator is the ID of the machine and the operating system and the clicks and everything else that, and if they have copilots, God help us. So the solution will not gonna solve the ways of working in the org. The org has to change a little bit the ways of working, which means they have to understand what privacy actually is for them. Because what privacy is for you is not identical with what it is for me. Of course, a big part of it is the same, but not all. And so without that understanding, what they're gonna see is that they're actually not really protected, but it's not because of your solution, it's because the way it has to be used if they want to stay private. So we see here, for example, requirements. Requirements, typically people think they are just a one way. It comes from somebody, a team, I know, decision makers, business analysts, and this kind of people, and it's one way from them to whoever deals with them, engineers, system engineers, ML engineers, and tech PMs and so on. But that's not what actually happens. What actually happens is that is a back and forth in between. Why? Because requirements are also from the tech side back to the business side. For example, you need to update your Java. Well, they don't know what JavaScript is or Java, let's say Java framework is, but they need to, all those servers and machines that they're using it, they have to do that update. That's a requirement, for example, sometimes a prerequisite, but it's a requirement. So that goes back to the business analyst outside of the container, right? Now that data, you would say, well, so what? It's just the release of this and the release of that. Not really. It also contains for whom is it? Teams and so back and so forth. Maybe not names of people, but teams. It contains a lot of other information that we can call it metadata. Given enough metadata, you can trace cradle to grave. It doesn't actually, those, what we see here, what the content of the requirement is not even needed anymore to trace cradle to grave, which means privacy is out the door. Yeah. So we saw there that in previous slides with encryption, end-to-end encryption, this and that. There's another misconception that encrypting everything keeps you safe. It doesn't. It just doesn't. It doesn't because it's just not enough. It's very good to have it, but it's not going to protect it on your own. Unless you encrypt the metadata as well. Not possible.
Yeah.
Not possible to encrypt the metadata. Everything will become slow. You don't control the metadata and so on. So is not going to solve these problems. No solution can solve those problems. So it has to be understood, how the solution works, but in the context. Where are those containers to sit? Are mobile devices involved? Because the moment they're involved, they're exposed. Why they're exposed? Because they connect to GPS. You say, but we're restricting GPS. Yeah, but you're on cellular as well. You're on public Wi-Fi many times. So essentially, mobile devices are exposed by the nature of the use and the purpose. So are mobile devices involved? Privacy becomes very much harder to assure. No matter of these containers, it doesn't matter. It doesn't matter because they exchange data and the end user not going to know exactly what data is exchanged with a host of third parties. In fact, you have to assume it's going to be the whole planet, because the moment people pay for it, they're going to get it. They don't get the data. What they get, it's the inferences out of models, out of, say, Google and Meta and so on. They're not going to see the data. They're going to have access to the profiling that those guys are doing. So this not going to solve that unless the businesses understands, well, we have to take care of what kind of devices are using these containers. So access is the most important aspect here. Access. What and where and whom and what for is accessing and using the output of these models and inputs data into the models and into the SLM that we see here, like these requirements, the private database and so on. Is it really private? But other than that, these concepts are well known. It's federated. It's mature concept. And sometimes it works, sometimes it doesn't, because again, the context around and how people do their business, that's what typically jeopardizes the solution. Well, sometimes a rubbish solution, but this is not a rubbish solution. This is a solid solution, by the way. So good thinking. And so the solution is itself is really solid. What would benefit, and this is what's missing, is technology providers do not educate the consumers that will consume the solution. So if in delivering the solution to businesses, you include a little bit of caveats around how best is to be used so that they will actually get that privacy that they are after in the business domain. Because in a highly regulated domain, they will look for certain things. In less regulated domains, they will focus on few other things, but privacy is still important. Even, let's say, it's a marketplace. It's not highly regulated. But guess what? Privacy is top. right there. Why? Because if people start saying, oh, this is not actually private, and my behaviors start being known by planet Earth, they will lose confidence, trust, and they're not gonna buy and sell anything on those platforms, which is an existential problem for the platform. So what we see is that privacy, it's an existential problem to solve for those guys, even if they are not highly regulated, and they understand that very well, I guess. So that moment when, again, the solution, I would say, tailor it to the customer a little bit. The principles are the same, the technologies are the same, but the way to delivering it is not a one size. Is not a one size. Okay, and true, they have to want to listen to you as well. Like if they don't really want to, they have the fixed ideas, do this in this way or else. Yeah, of course you can do it, but they're not gonna get the results. But if they're willing to listen, then there will be changes to you're not going to have the same solution for all. There will be some significant changes when delivering it. And that actually could alter the design very, very much so. Even the architecture here and there. You're still going to have this agent. They're still going to be, let's call it, small language models.
Yeah.
That's still going to be the case. But these private databases here, that may look very different. These green arrows here may become multiples in both ways and back and forth. That's what I'm talking about. So I would say, consider making it a mission to educate the potential beneficiaries of your solution by offering, how would I say, when I say educating, is not prescriptive, like in a classroom sort of thing, not that, but we say, please consider and come up with a few things after you learn about their business. And here is why we think of that. And then there will be a two-way discussion. Things like that. That's very powerful education if they want to listen. And the cost model as well. More privacy, more cost, right? More privacy, more cost. But that cost would very well be worth it. Actually, that cost, if it's reducing the risk significantly, then of course that's a saving. So you invest to save, right? It's not just some upfront money and that's about it. It's some upfront money, and then once the solution is obviously the cost reduces a lot, but you still have to continuously invest to keep it up to date to all these changes that are happening pretty fast in the environment and in law and all. But the risk profile reduces so much that everybody's happy. Again, they will have to think about that a little bit, but you can squeeze it into them. We are risk reducers, for example. Here is a few examples how we actually reduce the risk, not how we could, but how we actually reduce the risk. And few numbers, whatever you can share down there, or this they can see. Oh, okay, so we are in insurance. Insurance about all about risk, right? That's why insurance exists. And so, okay, so actually we can make a whole lot more money because of that, and simply because the risk for our business is much lower by using this. There's a lot of things, but this educational aspect really is very key, and that's missing almost everywhere.
Yep, I totally agree. And I know that, and Bogdan, honestly, these are really nice points. I'm happy to hear. I think the educational side is something I'll ask about, but now I'll let Yuvraj a little bit add up on this, because maybe Bharath can also add. Maybe, I mean, if camera is an issue, not a problem. Yeah, I think that would be great if you could. Yeah.
But could you hear us? Oh, he's like,
You're just on mute.
Hey guys.
Perhaps.
Thank you, Bogdan. I like the way you framed this whole thing. And I understand that the presentation as it stands is actually not tailored to a single business or a vertical. And if it is not tailored, then this two-way conversation, as you mentioned, is actually not going to happen, because they will look at this and say, interesting, maybe useful. And then they will walk away from what we're doing. So to answer your to other point, which is the costing, right? For certain companies, we are actually pretty sure about what exactly we are saving for them in terms of GPU hours, if it is about model compression. So we can actually price it according to the value that we provide to them, if it is a certain application that the enterprise wants. And again, we are not really like honed in and zoomed in on that application at this point. So again, that leaves room for us to explore. But again, when you leave room for exploration, then it remains an exploration and not really a solution that people will immediately latch on to. So in many ways, we are exploring how to actually create this value proposition in terms of the education, as well as also in terms of the costing. So yeah, thanks for those insightful comments, Bogdan, and also thanks for the questions.
Yeah, I would like to add a bit here. So, as first of all, Bogdan, thank you so much for the elaborated, the entire insights you gave, like much appreciated. And that made me thinking, and that actually made me realize the importance of this type of discussion even more. When I say this type of, I mean like between law and technology. The thing is that let's say we started talking about, let's say, if we are trusting Google itself or not, because Google literally having all the documents, like me, Bharath, whatever business model we have created, Google can like see it, everything. So that is true. But the thing is, these all type of tools we are providing, the technology we are building, it is catered to certain type of security system. When I say security system, I mean we have to define who is the trusted party, who is the not trusted party. For example, if we say like we do not trust Google Cloud anymore, then the type of solutions become totally different. We go for like our own hardware, we set up our own GPUs, or we go for confidential containers or something like that. That is one type of solution. But let's say Google Cloud Platform becomes a trusted party. And I think for governments, I think even government, I think they must be having their all the data either on Azure, Google Cloud Platform, or AWS. I don't think they are storing it on their databases itself. By creating their infrastructure and everything. I mean, for like a lot of Indian organizations, I'm pretty sure that's not the case. So what I'm trying to think here is that we really have to define the security systems, and from security systems, who we are trusting, who we are not trusting. And once we do that, then we can have like different combinations of these technologies, these architectures together in place to mitigate the risk, to follow the compliances. And that's where if the law is very clear, for example, let's say I was studying about DPDP a bit like last night. So like there are some kind of obligations on like data fiduciary when they are working with data operators. They have to make sure once that type of the work is done, the data operator has to like get rid of all the data that data fiduciary has provided earlier. So here the trustworthy the cloud platforms, the technology platforms are not the one who are not trusted party, are not the one who are malicious parties. Here, these are these different organization entities. There is no comment on the type of technology they are using. For example, if it is a Google's cloud, or if it is their own cloud, or if it is something else. So I think when there is a better clarity, so like we've been developing this type of solution, we talk to a lot of people, but I really think there is a lag, there is a resistance in different organizations to adopt privacy-related technologies because of bit of vagueness from the compliance side. And that is where, if that can be removed, we can pinpoint, okay, these 10 points which are mentioned in the act or something, you can actually like go about this using these 5 tools we are providing. But these 10 points is something like I at least find hard to kind of understand, or I find vague. And that's where like telling exactly these 5 are what you need becomes hard. So that is why I feel like these type of discussions are required. And I want to ask Abhivardhan, like, how do like people from the law side, they look at technology? Like when you say, like, I was taking the example of anonymization. So in law, like, is there anything like if you are doing an anonymization, it should have certain type of guarantee? Otherwise, anonymization could be just removing the name, but that's ineffective. How do you kind of think about those type of things in law? So this is also some type of questions I really had in mind for Abhivardhan and team.
So, well, on DPDP, we have the rules, of course, which came in January, draft rules, obviously. Nothing is implemented because even if the parliament has passed the DPDP Act, it's just not notified by the president on the official gazette. So
Okay.
it's just passed by
Oh,
the two houses. It's just like in the hanger. It's like in the shopping
okay.
cart. It has not been purchased yet.
Okay.
So, so one thing which is understandable is that more or less the security safeguards part in the DPDP rules focuses on not specific kinds of techniques yet, because it's like a plain thing to say that just maintain the safeguards. Because their understanding is that largely this is also something which is not being taken care of. So, for example, there's a company called Harmonic. I came across their fantastic report. In fact, if you wish, I can share it with you. So,
Sure, sure.
Bogdan, what happened? Yeah, yeah. So, Bogdan, in this report, they actually talk about these shadowy ways of using AI tools, because the employer provided AI software doesn't help them, so they go for the
Oh,
the free ones and all those kind of things. And then turns out a lot of cybersecurity issues are popped up, proprietary usage risks pop up. So I don't think that's a discussion. The same issue is the data localization. I mean, if you want to do data localization, what's the standard? You have the Telecom Engineering Center in the Department of Telecommunications, or which is, say, the Ministry of Communications. You should just define the standard. I think we never do those discussions because neither in the parliamentary standing committee reports, I'll be very honest, nor in any judicial discussions we talk about encryption standards very clearly. I think, and partly it is because I believe that the MSMEs are not represented when it comes to DPDP discussions. I'll be honest about it. So I think it's more like bigger companies and government institutions and PSUs. Their concerns are more there. So I think it's a thing in the open, but a better way to say is that I'll give you an instance. So
mm,
knowledge assets are an important issue, right?
yeah.
Knowledge management. So um, turns out the Europeans are a bit concerned. Why is the world not interested in their AI Act, which is so technical? But the world is interested in a non-binding standard called ISO 42001, which also talks about fairness, trustworthy, responsible AI. Because companies like Microsoft can implement something at a scale and it's non-binding, so it's more market practice. So, but I think in the case of India, I really don't buy this narrative that just because people are not quote unquote aware in a specific way, things can't be done. Because I don't think that's the case. People are aware. It's just that it's like a concept called Brownian motion in
Yeah.
chemistry. Everything is just rounding around wherever the hell it goes, like Heisenberg's uncertainty principle. But it needs to be converged in a trustworthy way, because there's no other way. And the traditional methods of giving feedback and policy making don't work anymore because of information overload. But I think that's where the answer to your question is, that I think basic level minimum standardization is something which is yet to be fully explored. Yeah.
Yeah. I also had one more question I wanted to ask you. It's like, what do you think, like, for Indian customers, I'm talking about Indian users. So, like, for them, like, for the building AI over their data, like, I mean, this is a very hot topic already. So, like, what is there already? What that people are, like, our government is building and everything? Because this is very crucial to me or companies like us, because we can go all day and talk about privacy, and these companies are only going to buy our solutions or like put efforts to take them or like inculcate them is when they are kind of have to maintain some compliance or something. They're obliged to do that. So yeah. So what do you think it's happening in that AI space in terms of rules and regulations for the users' data?
So I think cloud is definitely a concern, especially public cloud. Second is localization of tech governance or AI governance, whatever you call it, means the same. I mean,
Okay.
you can say the same for blockchain also. A lot of times the problem is people just don't understand that it's very simple. It's about localization of value chain. Now you might not need a binding standard for this, but you can just do it within a market standard approach to keep things safe to the extent you can. Because I think the problem is it's not about parliament or anything. It's such a big country. Uh, okay, so let us. So there was a competency framework which came for public officials, right? And I had to make a critical appreciation stating that it was not helpful. Why was it the case? The problem is, imagine a local DM or ADM, assistant
Mhm.
digital magistrate, sorry, digital district
District
magistrate.
magistrate.
I apologize. But we will have Indian digital services very soon. In 10 years, there's some proposal going on. But let us say we have the district magistrate. And that district magistrate is like, you know what, let's make things accessible because that's all digital India is, right?
Yeah.
And you use that AI chatbot. And turns out its API key is leaked because coding error, freelancers
Yeah.
do stuff
Yeah.
which
Yeah.
is not well tendered. And then something happens. Claude bans you or OpenAI bans you from using the API. And then you are stuck because the end user, that is a citizen or the business which is involved through whatever the initiative is. Because I think a larger problem is a lot of DPI which is built in India is over actually a very older infrastructure, which is exactly why third party risks actually
Mhm.
emerge. It's that with the PSUs also, I think um, they need to be told that it's a risk problem from a very clear operations point of view, rather than saying that, because at the end of the day, what will happen is that firms like yours might become intermediaries in their own way,
Mm.
like consent managers, okay, under the
Yeah.
IT Act, whatever,
Mm.
maybe it will be the Digital India Act, but Section 79 or 79A, I think you all will become intermediaries to an extent because firms like you are needed. I'll be very honest. And um, I don't. I also say as a technology law specialist, it doesn't reduce my work; it only increases my work, or for anyone, because there is something called explainability to these technologies
Okay.
and the know-how sense. Okay,
Mm.
you will need someone who can make these things talk at a very
Yeah.
basic level, because lack of laws is gonna be there for 10 years. It's just misdirected conversations. I think there's lack of documentation. We don't know the market ecosystems, but it doesn't mean that the market doesn't need it. It just means that it's not just properly funneled, which is also a thing.
Yeah. Yeah, I see. Like I've been watching a lot of interviews on this DPDPA thing, and I think recently some like consultation period has gotten over, so people have become more excited about it. Like I saw like multiple interviews very recently, but for the enforcement part of it, there was no clarity on like when will it be enforced. The vague comment was that the sufficient time will be given to everyone. Now there's no definition to that sufficient time here. So yeah, I mean, when I heard about the DPDPA thing, like the concept of this consent and everything. So we have actually mentioned the Web3 in like one of the agendas, like consent and all. Like this plays like a Web3 can be used very well there. But if you're there, like if you want to speak on like this consent and Web3, like we have
Please.
actually like done something around
In
that
fact,
also.
I have myself written a report on Web3 and cryptography use
Okay.
cases and policy. So, Bharath, please.
Okay.
Yeah.
Yeah, so we have done something as a small work for a DPI provider in based out of Bangalore. They call Indian Urban Data Exchange. They are sitting within the Indian Institute of Science, and yeah, so they needed a, a trustless solution for consent management. One of the problems that they were facing is if this IUDX platform is to exist, or one of their other platforms, the agricultural data exchange platform, is to exist, the farmer who gives consent to IUDX, in this case, IUDX has to maintain the the record of that consent and also manage the consent and make others trust that this is, I mean, IUDX is not playing with this consent. And that's one angle. The other angle is we should not be liable to any kind of privacy related law problems when it comes to this consent management module. So the solution there is to have this consent management module alone on a blockchain. So here we can actually encrypt certain data and not really expose the farmer's information. We can actually put certain things in the metadata and like some wallet ID of the farmer and all that, and we can store all these wallet IDs plus the farmer name, etc., in a different database within IUDX. But just that the reference, the farmer's name should not go onto the blockchain in and of itself. So it's a very simple system that takes the information that the farmer gives and records the consent, and there's a policy that ensures that if the farmer revokes the consent, then that is also updated on the blockchain, and the data consumers, be it other organizations or individuals in this case, they will be notified that this farmer has actually is not, I mean, his data is not available to consume anymore. So that's one thing that we did in this particular space. It's tangential to what, in terms of the business angle, to what we have here in the slides. But I have some work in that domain as well, the Web3 domain and the AI domain, basically along the lines of federated learning, the diagram that Yuvraj is showing here. But instead of the orchestrator being some server, then the orchestrator will now be a blockchain smart contract that does the federated learning, orchestrates the federated learning. So yeah, I mean, technically we are pretty sound, but I go back to Bogdan's comment that in order to have a two-way conversation with a business or an enterprise, we need to tie down these technological innovations and concepts to something tangible for them, so that they understand the value of this proposition. Otherwise, it becomes a very, very hard sell.
Yeah, totally agreed. And I think I might be interested to catch up with you later about the Web3 plus privacy plus federated learning side, because this is something which intrigues us as well. Although
Okay.
I believe that it's not something which is that much tried and tested in India. Very few entities have done, like you mentioned. But I might catch up with you later on this. So I think
Sure.
because of this, but yeah, there was definitely a question through among the discussion points about the three integration with AI-based privacy preserving. I think we've kind of addressed that. I think privacy practices and the DPDP, I think we have also discussed enough in my view. So I think this is great. But yeah, I think to conclude, I think I will let Bogdan add up quickly, maybe for 5 minutes, and then we might conclude it up. But yes, the recording will be shared on YouTube for sure. If you have any.
So here is a use case that was, all these LLMs, they don't really have obvious use cases. Gen AI in general, right? People had to scratch their heads to see. It's not like the wheel or the transistor, the microchip, the integrated circuits, the semiconductors, and so on. And for a while, the following use case was hypered beyond belief. The use case is valid, the need is valid, but is not at all addressable with LLMs. Like it just isn't. internal organization, when there's so many documents, duplicates, triplicates, incomplete, this, that, in all sorts of parts, or one single department, let alone an entire org. Talking about a big department, not a 20 people department, talking like a couple of hundred more department. And so how to organize that? There's data lakes, this, that. We all know data lakes not solve that problem because of user behavior and all. But what if you have an LLM of sorts, and you just query the prompt the LLM, and then they extract the stuff that you are after? Well, obviously it doesn't work. Why? Because that data is not maintained the same way across the org. So the LLM not gonna work because of that, in principle, unless the whole data repositories are reorg, which we know nobody does it well. Not Google, not nobody. The messy aspect of the world. But here is the thing. When it comes to privacy, because that's what you try to solve here, right? Privacy. You don't want to reorganize, we give you a solution to reorganize all your data and your knowledge and blah, blah. That's not it. That's pies in the sky. But the privacy is not a pie in the sky, right? So what if your solution is pitched to say, in an org, there are several departments, the privacy needs are not exactly the same. There's a common denominator, but when you look at HR, much stricter, okay? Much stricter compared to, say, I don't know, IT, marketing, and so on. Marketing has secrets, right? It has secrets. They should not, but that's not privacy, right? Secrets is not privacy. That's confidential data. That's not privacy. Privacy is about people. Privacy is about people. And so HR, for example, anything to do with employee data, not just HR, right? Anything to do with customer data. Customer service is a good case in point. HR is a good case in point. The legal department is a good case in point. It's full of SPII data, full of it. And so this solution can say, this is how we essentially protect your privacy better than the established solutions out there. Because we bring something that is new. However, the concept behind them are very matured. The technology is very matured. We just make them work in a different way that is not a copy-paste between orgs. What you have, nobody else's have. The type of deployment you have, it's for you. It's not for another org in the same domain or business. It's for you. It doesn't exist anywhere. And so internal information, internal data, it's a huge use case for your solution, I would say. HR, customer services, probably other areas, but these are the big ones that come up from my head. And so why? Because public clouds are not involved. They're not gonna put that employee data on public clouds, trust me, unless they just totally incompetent. They just won't put them on public clouds. Yeah, transaction may go through public clouds and the whole of other information and some employee data, for example, I don't know, name and email address and things like that. They're not gonna hold, say, disability status on public clouds. That would be a huge mistake. Or I know, anything to do with biometrics. I know, like type of blood that they have. In some orgs, you need to have that. It depends. Like that's not going to be on the public cloud. But it will circulate, right? The metadata. So that's a big use case. Internal data. It's a big use case. Organization always talk about we are private, and obviously Google Cloud will tell you what they're gonna tell you. We don't really care about your privacy. Well, they don't really. They only care because of the law, but otherwise, their business. They wouldn't exist if privacy would be enforced proper. So, but what you do, you offer a workaround. And probably starting with the internal data that they have, the org data that they have. You protect the privacy there. and customer data will be involved too, but you can talk about, things like employee data, for example, with this solution. That is, it's also scalable, right? It can be done plug and play. If they say, what if we have an entire new business line coming up? You just say, well, this is modular. You can add more modules. You can remove the modules through an automated process that you control at all times, and you have oversight at all times. And we are just in support capacity if things break down. That's it. So that's really the huge value I see in that. No new technologies involved. I mean, new as in zero maturity. They may be good, but they're not proven. Okay, that's not the case. Then the modularity aspect. Then it can run anywhere. I mean, obviously they can put it on public clouds if they're silly, but technically, but it can run anywhere. And the other thing, no big models involved. When I say big, I mean those over 20-30 billion and parameters and all. And also they don't have to consume those models from, say, OpenAI, for example. They can do, but they don't have to do. With the solution is not prescriptive. We use Claude on this and that. No. So the proprietary aspect equals privacy. Like, you can't be private if your key information is not part of a proprietary model. It's not gonna, like, your privacy is out the door. That's it. No matter what Google said, it's out the door. As simple as that. But that is private, right? You already put that private, right? This is very important to maintain there. People soon will realize that this connection is the only way to protect their privacy. But what you do here, you could say you don't need to disconnect necessarily, because with the solution, you just connect to where it makes sense without jeopardizing your privacy, right? It's smart, it's really smart, but that has to be explained a little bit to them, because it's not going to be too obvious. Like, that's why the right keyword at the right place is important. Private in the middle, private around. The more they see this type of keywords, and then they are enforced by, like, seeing it working, right? They can test it, they can demo it, they can ask all sorts of task questions. You're going to have an answer, and they'll say, man, this is really reducing our risk big time and our legal exposure big time. Yes, that's, I think that's where the value is.
Yeah, I think definitely we do look for, I think this private data of the employees and related to HR and everything, it's very crucial for maintaining the privacy. But I really think, like, at least in India, a lot of startups, like with even a number of, let's say, couple of hundreds, they have all their data on like public cloud. So, I mean, yeah, so like people have to kind of make a lot of progress, like in terms of the privacy. So what I'm trying to say is we have this level of privacy ensuring technologies that we have already. It's just the adoption is still lagging behind because there is no enforcement for that, at least in India. So that's the gap which can be kind of filled by like good laws enforcement. That's what I believe personally.
In government is right. I don't think a minister of a state, I'm not talking the prime minister, a minister of a state wants the habits of clicking on website be known by the Indian subcontinent and sold on the dark web to the highest bidder. Look at what they're doing. They and actually weaponized politically. They are pitching, we are reducing poverty, and the guy is clicking on Rolls Royces on website like there's no tomorrow. Yeah, it's funny, but it happens. So the guy's into Rolls Royces all the time, and he's pitching that he's humble and doesn't spend and eats like really only once a day. And I mean, he has a belly, but he's trying to reduce and by eating just once a day. and essentially being like very modest. But half of the day he's clicking between Bentleys and Rolls Royces and Switzerland, venues and all that, right? That is easily weaponized.
Yeah.
I'm exaggerating, of course, but you get my point.
Yeah.
And they will be very they will be very sensitive to these kind of things. For example, so government is a really good. First of all, is big and diverse. Yeah, it's bureaucratic and all like everywhere, true, but it's big and diverse. It's typically long-term programs, and it has a lot of sensitive data that needs to be protected. I'm not talking about security here, I'm talking about privacy in general. Like the decision makers' data, but also the people involved. If that discovered that it's out in the press, we don't really care about our constituents' private data. I mean, yeah, they don't, but if that's found out, right, there is not to be found out. Not that they don't care. But it's out in the open that we don't care. That's the problem, right?
Yeah.
So you see what I mean? So by
Yeah,
actually protecting these nasty interests, you actually you do good to the people that are actually right now not protected. The privacy is not protected because those guys will take care, because otherwise it's their job on the line and their political career on the line. And it goes the same with the commercial organization. I think Abhivardan will know more about me there because, well, Lucknow and everything, he knows what's going on more than me. But really, I think that's where Abhivardan, you should really talk to people about these guys.
We'll be happy to. I mean,
you should really talk to people about these guys a little bit and just say like, they know what they're doing. They're not fancy. They're not fancy. Like they're not fancy. And I'm sure you're gonna give a demo at any time. Give her like a limited free trial or something to try them out as POC or something to see it in action. And actually, because the benefit realization will be quick. We are not talking 6 months, 1 year down the line. We're talking like a month. Like in a month, they're gonna see the results. So this they just have to be put in front of right people.
Thanks, Bogdan.
Yeah, I totally agree, and I think we can take that aspect of the discussion forward. So I will be anyways closing the recording first. That we conclude the session.
And it's not exposed, right? Trumpistania, it's a big element here. These guys are guys that are not like rappers, like they don't take some LLM